You are watching the 3.2 lesson on graphing linear functions day 1. Now, I know that you guys graphed linear functions, and what I mean by that is lines, so much in 8th grade. So this might be review for you, and that's great. A couple things that I just want to point out, which I'm sure you're already aware of, is when you graph a line, we should plot at least 3 points. I say graph as many that will cover the graph. That's a minimum of 3, but as many as you can get on the graph is best. We're going to connect your lines with a straight edge, which is going to be kind of tricky for me to do on this device that I'm recording this video, but I'll try my best. We should draw arrows on both ends of our lines to show that they extend in both directions. And this kind of goes along with A, is make sure your line covers, there should be an S there, make sure your line covers the entire graph. Looking back, this is our parent function, y equals x. So if we just think all we're doing is transforming our parent function, we are either going to shift it up or down and probably make it steeper or less steep, which is almost like narrow and less narrow or wider. All right, so let's begin. We like to graph our lines when they are in slope-intercept form. I do remember when I talked to Mrs. Schmitty and Mr. Fisher and Miss Hurleman, they said that for M, you used move, that's how you move, and the y-intercept or the B is where you begin. So this might be helpful to connect from what you were doing last year to the awesome stuff that we are going to do this year. All right, so number 1, f of x is equal to 1/2 x plus 3. Remember, f of x is the same thing as y, potato, potato, so this is just y equals mx plus b. All right, so what is my y-intercept? Where do we begin? 3, and my slope is 1/2. Okay, let's start plotting our points. So we begin at 3, so 3 on the y-axis, and for our slope, that means we need to go up 1 to the right 2, because they're both positive. So up 1 to the right 2, up 1 to the right 2, and we're going to do this so that we cover, and this is kind of hard for me to graph. Okay. We can also go down 1 to the right 2 to follow the same pattern. All right, so once we've gotten to this point, let's connect our points. I'm going to try using a straight edge on my iPad screen. Let's see how disastrous this is. Oh, this looks terrible. Okay, is this any better? No, this is horrible. I don't know if I can do this. All right, sorry guys, we're gonna just have to freehand this. I found a line tool in here, so I had to pause the video for that. Took me a little bit of time, but here we have our beautiful linear function. I'm drawing arrows on both sides, and I'm going to label this f of x. Some of you might say, do you have to write all of this? And my answer is no. Because we have our function notation here, we can just label it f of x and be done with it. Yay, so exciting. All right, let's move on to 2. Hopefully I'm not going to have as hard of a time graphing as I did in the other one. Let's zoom in. All right, 2. How do we graph? Well, we need to know where we begin, which is our y-intercept, which is the -5. That's always the constant in our function. And our slope is 3. But that's not going to help me out. I need to give that a direction. That just tells me to go up 3. Let's write it over 1, because 3 divided by 1 is still 3. So my rule will be up 3 to the right 1. Begin at -5, down below here. So if I begin at -5, and then I go up, let's see, up 3 to the right 1, up 3 to the right 1. I'm going to do this to cover my whole graph. All right, so I had to pause the video because graphing on this iPad is disastrous. So let me just highlight what I did. I started at -5, I went up 3 to the right one, up 3 to the right one, so on and so forth. I can also go down 3 to the left one to generate the other part of my graph, which I definitely want to do. I drew arrows on both ends of the line. You did too. Nice job. And I know you're ready to yell at me. You got to label it, Mrs. Ruscio. Thanks for the help. All right, let's move on to example number 3. Okay, what's my y-intercept? Hopefully you are on fire right now. You are telling me that it is 1. Good job. So that means on my graph, I am going to begin, because that's my B. I'm going to start here. And then my slope is -3/4. Now, I don't want to write it with that negative out in front because that can get confusing. So my advice is bump it up. Always move it to the numerator, the top of the fraction. So, my slope here is a little different. It's now telling me to move down 3 to the right 4. So that means down 3 to the right 4. All right, so here's my line. What I did was I went down 3 to the right 4, down 3 to the right 4, up 3 to the left 4, up 3 to the left 4 to generate the whole left-hand side. Of course, yes, I'll put arrows on the end of the line. Thank you for reminding me. Of course I'll label it. Thank you for reminding me. So here is our graph. One thing just to point out, we can see that in examples 1 and 2, our slope was, our slope was positive, so our line increased. Obviously, we're increasing at a faster rate because 3 is bigger than 1/2, but we're increasing. Moving on to example number 3, and you'll also see in example number 4, we have a negative slope, so our line is decreasing. Let's jump into example number 4. Now, I don't have a y-intercept, or it's just not written in there. So what can I add to something and not change its value? Well, if you're telling me 0, you are correct. So the y-intercept, I begin at 0, the origin. And then what do? Well, my slope is kind of weird. It is the number that's in front of my x, which is actually -1. Because there's not a number there, so we always write in 1, but I want to turn this into a fraction, so it's easier for me to give my line a direction, divide it by 1. So, down 1 to the right 1. Down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, or up 1 to the left 1. I'm going to pause the video. You can pause it, or if you can pause the video if you want, but I just need to pause it to start plotting the points. All right, so here you have it, my decreasing line because of that negative slope. I always like to check that at the end just so I know that I didn't plot my slope backwards. That's usually one of the biggest mistakes that I see when people are plotting points. And my y-intercept was the origin. It started at 0. I drew my arrows, I used a straight edge, and I labeled. On the following page, it looks like we need to first translate and then graph. So what I'd like to do with all of you first is translate, because I think that's where a lot of us struggle. So we need to use our keywords. I would completely suggest, whoa, what's going on? I would completely suggest all of you right now to take out your translating word tip sheet that I had made for you, because that will definitely help you. It's the one that says like translating words in the middle, and it looks like a bunch of bubbles off to the side, adding, subtracting, all that fun stuff. Okay, so y is twice x plus 4. Well, a couple things I'm noticing means equals. So y equals twice x. Well, twice x is 2 times x plus 4. And remember how I think I mentioned this a lot in the first unit. Instead of writing twice x as x times 2, write it as 2x. Well, here's the reason why. It's a lot easier for you to see that 2 is where you begin. Oh, excuse me, 2 is how you move, and 4 is how you begin. All right, let's move on to number 6, translating. We'll get to the graphing in a minute. Y is, okay, y equals, means equals, half of x. half of x. Half of means multiply, so half times x, 1/2 x. All right, 7. 1 less than. Ooh, 1 less than means I'm taking away 1. What am I taking 1 away from? X. X times 3/4. Oh boy. X times 3/4. Well, I don't want to write the times 3/4 after my x. This looks like 3/4 x is, there's my equal sign, y. And I could put the equals y at the end here or at the beginning. It really doesn't matter because they're the same. So y is the same thing as that. I'll put that at the beginning. All right, number 8. Triple x less 5 is the same as y. All right, triple means 3 times. So 3 times x, triple x, less 5, means we're taking away 5 from that, is the same as, well, that's equals y. So again, I'm just going to put y in the front. I could also write it at the end. It does not matter. All right, number 9. Y is 4. Oh, this is easy. Is y equals 4. All right, how about 10? X is -6. Ooh, x is equals -6. All right, so what I would like for you to do right now, since you just got a ton of practice graphing on the first page, take a minute, pause the video, and I want you to graph all of these. Actually, no, I take that back. I want you to graph 5, 6, 7, and 8. You don't have to graph 9 and 10 just yet because when we pick back up in the video, I will do that for you. But right now, I'm going to create the answers, pause the video, and then after I return, you can check your beautiful lines. Okay, here you have the answers to 5, 6, and 7. If you need to, you can pause the video right now just to check, because I'm moving on to 8. So a couple things just to keep in mind. Arrows on the ends. Labeled, unfortunately, it didn't say f of x, so we have to give this equation the entire name. Again, positive slope, positive slope, positive slope, increasing line, increasing line, increasing line. The same as 8. Triple x less 5 is the same as y. We were looking at a positive, pretty steep slope here. And I labeled with arrows and used a straight edge. All right, let's move on to number 9 and 10. Numbers 9 and 10 are similar but almost opposites of one another. And the way that I like to graph these is I think back to Unit 2 when we were given the x value and we had to find the y value, or vice versa. We were given the y value and we had to find the x value. So when we look at our graphs here, we can see that in number 9, y is 4. So what I do is I go to where y is 4, which is right here, and I just draw a line straight through all of those points, just like we would do in Unit 2. So here's my line. I'm going to put arrows on the ends of it and change the thickness and just label y equals 4. Now on the flip side, so we can see this line has a 0 slope, so let's make a prediction. What do you think is going to happen when x is -6? Well, let's first plot where x is -6, so I'm going to go to my x-axis. There it is. That is where x is equal to -6. Let's draw our line through all the points where x is always -6, which happens to be this line right here. Arrows on the end, and label, and we have a beautiful vertical line that has a slope of basically undefined, or actually is undefined. So that's a wrap. I hope you had fun graphing lines. We are going to do this again in the next lesson video, but just kick it up a little bit of a notch.